Right, welcome everybody. Here we are on the morning of the Gauge Guild's spring virtual show. So welcome to all you early birds. And this morning we've got Lee Styger, who's going to talk to us about some aspects of 3D printing. And I did see a brief excerpt of what he's going to say today earlier, and I have to say it's very, very, very interesting. I was absolutely intrigued by it. So in a minute, I'm going to hand you over to Lee. In the meantime, can I just do a bit of housekeeping, because Lee's asked that if you want to ask a question at any point in his presentation, just unmute yourselves and ask it. So again, if you want to ask a question, just unmute yourself and ask Lee, and we'll take it from there. If you do unmute yourself, please make sure there's no washing machine or Radio 4 or dog barking in the background. That will kind of help us. So over to you, Lee.
Okay, thank you very much. Good morning. I was going to say I'm phoning from you. I'm zooming you from Australia, so it's getting near my bedtime as you guys are waking up, and hopefully you can tell by the accent that I haven't always been here. So it's a pleasure to hit back to the old country. I want to take about an hour of your time if I can. If the questions and answers go on, then it'll be a lot longer. And go through aspects of 3D solid modeling, in this case for 3D printing, and hopefully by the end of the time we'll get to a little bit of an output from this. To do it, what I've done is a short presentation, which I'll start off with, which is really just pointers for myself to get the show rolling. We'll break about halfway through to go live to the CAD system, and then I'll wrap up with a few thoughts afterwards. But between all this, please feel free to ask your questions as you go along. If you're unfamiliar with CAD, then where we take this is from a 3D modeling point of view, not 2D drafting. But there's a little note somewhere in this presentation that says that if you want to know more about any of it, 2D or 3D, then please just contact me. There's an email address at the back end, and happy to enter into correspondence or more Zooms to get these things going. So I'm going to bring this presentation up now. Hopefully you guys can see that. Can I get a thumbs up from somebody that you've got it on the screen there? Great. Now, again, hopefully this is going to work for us. The model I'm going to use, and I make no apology, is an 1865 goods van from the Talyllyn Railway. I'm a narrow gauge modeler, and I was going to keep it to something I felt a little bit familiar with, and hopefully you're not too familiar with it, so the nuances of the prototype then can get left behind in the wonderful world of CAD. But fundamentally, we're going to go from a little bit of a drawing into the model you see below. And at the end, so long as I remember to do it, and if I don't, please ask me to do it, I'll show you how quickly these things output ready for 3D printers. As we go along, I'll explain my thoughts on CAD modeling for model making as opposed to CAD modeling for engineering, and that there are subtle differences for the sorts of things that we want with the sorts of things that we do for the hobby. And the aim, hopefully, for us get a little bit of motivation, a bit of encouragement. It's not that tricky. There are some skills, some tips along the way. But like all of the stuff, we have to start somewhere. So hopefully it'll give you a little bit of insight. When I got back into the hobby a few years ago, my master plan was to basically do all my modeling on a kitchen table with a bread knife. A few years ago, I really fell in love with the range of narrow gauge stuff from Right Lines. Came back into the hobby to find that you can no longer get this stuff. So I was left with some big choices, not to bother at all. Scratch build, which I still thoroughly enjoy. But the time, the consistency was a little bit of a trouble to me. So I had this bright idea that I'd pick up a CAD machine and start to manufacture my own. And and what could possibly go wrong. I kicked off trying some of these free softwares you can pull from the internet, but they were very, very limited, incredibly frustrating in some cases, and really didn't give me the fidelity I was looking for. Doing a bit more of a search, some of the more well-known systems, the AutoCADs, the SolidWorks and so on, fabulous systems, but they're all known as enterprise-wide systems, so they'll do a whole organization or whole supply chain, and the price tag comes accordingly. And they were completely out of the price range for me. I fell across this thing called Rhinoceros, and this is the one I'll be using today and have done for the last year or three. Incredibly well suited to everything that I need from a model making software. Fully functional. It'll do everything from basic 2D drawing through to full solid modeling. You can output that to a range of files from 5-axis machining through to rapid prototyping or 3D printing through to 2D drafting. It's never let me down. And as I said before, incredibly affordable, will run on a Mac or a PC. Before anybody asks, I have absolutely no affiliation. I'm just a very pleased customer of these guys. So I do it. Well, we've all had tough times over the last year. I was hoping to get to Guild-X again this year. It's not going to happen. And obviously with the Guild doing these shows, I put my hand up thinking that nobody'd have any interest in 3D CAD modeling, but I'm quite surprised. A bit of a soapbox as well, kicking around in Australia on some of the shows and forum and things, there's an awful lot of myth and legend around CAD and what people are using it for. And I've seen an awful lot of poor output from CAD models, and it really has let people down very, very badly. So I thought if I could provide a few pointers, then it might help. It's a good time to share, it's good to share. And, you know, tongue in cheek, I've now sort of ticked the box for being a Gauge O Guild exhibitor, and hopefully I get that little plaque for my train set at some point, but we move on. Some principal assumptions, okay? We've got three different kinds of 3D modeling in effect, and the picture on the top right there hopefully illustrates them for you. You've got the idea of wireframe, which basically provides the extremities. You might be familiar with that from 2D drawing, but there is a 3D application for it. You've got surface modeling, which basically puts a skin around that wireframe in its simplest form, but has nothing in the center. So it's imagine it as a sort of World War I aircraft wing, and you've laid the canvas and dope over the top. The other type is solid modeling. That's what we're going to cover today, and it's an absolute. The computer sees the model as having mass. You can add and subtract from it, and it's the easiest thing to export for things like 3D printing. It tends to be more foolproof in the way you go about modeling with it, but there are some little tricks to the trade, and one that I'll show you come roof time with the van, that I'll mention now, is the butt jointing of two solids. Although you can do that on the system, often when you output that for 3D printing or CNC machining, the conversion into those programs drops them back to their original native primitives. So you end up with a bigger bag of bits than you were necessarily expecting. I'm assuming that people are reasonably familiar with 2D CAD, but as I said, if anybody's not and they want to pick up on this, I'm more than happy to talk you through or provide pointers off screen to this session. Our basic modeling technique today will be to take a series of primitives that we create, some cubes and flats and things, and put them together to make this van. The other thing to point out as we go along, and there's been a lot of debate on this, I model narrow gauge in 7mm scale. I'm tempted to model broad gauge in 7mm scale as well, which means that my CAD models are all to 7mm scale. There's word on the street that, what we should be doing is modeling one-to-one and then scale them down. But models or parts of models don't necessarily scale sufficiently so that we can actually create robust models. So the little Telflin slate wagon you see on the right-hand side of your screen, the little rusty floor there is about 0.5 of a mil. Now that's 3D printed. The little uprights that hold the planks apart, they've got a diameter on them again of about 0.5. It's as small as the technology will allow, and they've had to be beefed up enough just to make this model work for me. So if I was to scale from 1-to-1 down to 7 mil, I'd still get an awful lot of rework necessary just to make the model. So others do different things, but I've found that modeling to scale I'm working in is far more robust than anything else. So, the telephone wagon that we're going to build, we know back in 1865 there were at least 3, and we know that they had different profiles. We're not quite sure of the original door detail. We think possibly that there was a 4th, and that's basically what we're going to be producing for the rest of the show. Now, I'll be doing this live, which means that in a second I'll go from this screen to the CAD screen. I'll talk you through the whole process of making the model. If you're unsure, please ask questions. If you want me to slow down, please ask questions. There's no right or wrong in terms of the methodology on this, but hopefully you'll get some insight into how I do it. Okay, so I will stop sharing this screen. If I can possibly do that. There we go. Sorry, I have to do that first. I'm now going to share the other screen and get us onto the CAD system. Okay, so can I get a thumbs up that you can see the grey screen with the drawing? We're okay on that. Now what you're looking at there at first sight would appear to be a 2D drawing of the van we want to make. It's not. It's not an engineering drawing by any shape or form. It's basically the red lines that you're looking at are just 2D drafting lines or marking out lines, similar to what we do on a sheet of brass or a sheet of plasticard. Sorry, I've just got a reminder from my machine to do something. We've got some dimensions. They will help us in a little while. And to the right, we've got 4 door types. The ones that we're going to use this time are the red ones, and on the previous models, we've used the white ones. So what I'm going to do is move over to the right-hand side of the screen. You can see the layers down the side. Now, layers allow us to work, if you like, on clear sheets, all in the same distance apart. And I can now hopefully switch those guys off and just leave the little doors that we're going to use. And really, it's all the data that we're going to need. I'll move now to 4 screens, which is up in the top left here. And what you've now got is the top, the front, and the right view, plus the perspective view. And simply because of time limits, I've created a standard chassis in 3D solids already, and the idea will be to create the body that will drop onto the chassis. So as we work forward with the model, what we will be using are fundamentally these 3 screens to draw our entities, and we'll be checking them and cross-referencing them on the perspective view. We'll be tending to zoom in and out quite a bit. I apologize. I think watching this on your screens might give a bit of vertigo. But apart from that, as I said, if you need to check anything as we go along, just please raise a hand or ask your questions accordingly. So fundamentally, we'll go back to our front view to begin with. And what we're going to kick off with doing is getting rid of our measurements, because all we're interested in from a modeling point of view is actually the outline shapes, and these are the shapes that we'll be creating our bits and pieces from. Going into the 3 areas, changing our layer to our body layer. Now, we have different active layers. So these are the layers that are on show, the little light bulbs. But by clicking here or here, what I'm doing is creating an active layer to model in. So I'm going to create a series of planks in the body 3D. We've got little outlines here, here, and here for our plank profiles. And we're going to extrude a plank from these profiles. Now, first tip, just going to the right a second.
Lee, can I just ask, what's the name of the software, please?
Rhinoceros.
Oh, right. Sorry, I missed it right at the beginning. Thank you. Cheers.
You can get it off the web. It's very inexpensive. And there's a note coming up at the back end of this. I think they still do it, but they allow you a free download for 3 months. And it's not a light version or anything else. It's a fully functional version, which means you can output this. You can create STL files for 3D printing, 2D drawing. You can export to the CAD system. So the whole thing is fully functional. And tongue-in-cheek, they're puppy dog selling, because by the time you've had 3 months of good practices with this, you don't want to change to anything else. But it gives you the confidence to pay the price tag. And I think I paid about $500 for it, which in CAD terms isn't a lot of money, but it's more than paid for itself. There's no ongoing license fees with it or anything else. So, once off gets you everything you need, and they keep sending you the updates as you go along. Okay, I just want to draw in on these planks for a second. Now, hopefully you can see the 3 different sizes. These telephone vans have different plank sizes for some strange reason. We would assume that a plank in the real world would be sort of oblong shaped. But what I've done here is created this kind of cruciform shape. And the distance between here and here is about 1/4 mil. And experience has shown that if you chamfer the edges of your planks to give the plank definition, or if you fillet, put a round on the planks to give plank definition, although it looks fine within the CAD model, when you print these things, often that definition can be lost. And this kind of 1/2 mil, once you put a couple of coats of paint on it and done everything else you need to, is about right to show you the plank definition from a reasonable viewing height. So in one respect, it's horribly overscale, but from a modeling point of view, it's about right for making the thing you're looking for. Okay, so what we're going to do is we're going to choose one of our planks to kick off with. And if I can just pull this up a little bit bigger for you. These are our plank profiles in the front view. We want to extrude from left to right in the front view, but obviously the different orientation in the right view. So by picking on one of these guys here, I get a choice of the big one, the medium one, or the little one. Or if I was to pick on them in this view, you can hopefully just see it starting to light up there, which is the little one, medium one, or the big one. And we're going to take the big one to begin with. We go up to the top to solid. Can you actually see the top bar on this screen, or can you only get to where it says TR covered van? Nobody can see
just
the top
about. On my screen, you've got something slightly over the top, but you can see the bottom half of that.
Okay. This is
That also playing a smart track, Gumball, and history.
Yeah. Okay. This is going to be a bit irritating, but on the top bar, like any other piece of software, you've got your main commands. Standard stuff if you can't read them on your system, which is file, edit, view, curves, surface, which is your surface modeling, solid modeling, which we'll be using, mesh, which takes us back to the surfacing again. We've got some dimension stuff that if you were doing 2D drawing, you'd be using that. But there's a little side bar for those things for us. Transform that we'll use quite a lot, and some other tools and analysis and render and things that we won't be using. So going up to the top there, we use solid. Now, has this dropped down enough for you guys to see extruded planar curve straight?
Yeah,
Yep.
you can see the drop down.
That's okay. That's all we need in this case. So we're going to go straight. Now, can you see immediately it's allowing me to drag this black entity? Reason it's black is because the color of our active layer is black. This is where we start our plank in line with the body. We bring it over to here. We've got a snap on the grid size. We do that and just bring it back to full. In the 2D view that you're looking at the moment, we've got a black entity that looks a little bit like a plank. If we go to full view, you can see where the highlighted extrusion is still there, but what you've now got is the first of our 3D parts, which is a 3D plank. So what we now need to do is move it to align it to our little outline. So go back to front. Now there's another little trick with this, that you can choose different areas to drag on. The problem is that as the model gets more complex, we might have about 5 or 6 different points here, all 0.1 or 0.2 of a mil apart. So when you're dragging entities, come to a nice clean entity, you can take it straight up and it'll align then with our 2D entity, which is exactly what we want. We're going to make some more planks, this time medium-sized ones, because that's what the drawing requires. So we go back up to solid, extrude planar curve, straight, and exactly the same principle arrives. So there we go. Now, what I want to do is we can see we've got one of the planks here aligned. This is our next plank aligned. Now, to make our life just a little bit more easy, we're going to drag that entity over to align with the red 2D. We're given an option then to drag this one. And I'm going to take him and join him there. Now, up in the perspective, you can see that we're starting to build the wall of the side of the van. But what we've got here, and we get back to it shortly, is we've got a butt joint between these two entities. So there's nothing effectively nailing them together. The computer will see them joined if we choose to join them, but there's a little trick I'll show you once we've built the side of the model, so that we can ensure that these things are actually there and perceived by the computer and any of the software later on as a full solid. So very simply now, we're going to edit, copy, edit, paste. It's another little one that we can then drag on top. We go back up to edit, paste. Another little one we can drag on top. And so the 1 or 2 more, it's probably one more. Edit, paste. Go back to where I can find it. Okay, so if we look in the front view, we've now got our planks aligning to our outline. We can see in perspective, we've got our planks all aligned together. And if you look in the right view, there they are, one on top of each other. But at the moment, each one of these is a separate entity. They're not joined in any way, although they are solid models in their own right. So what we're going to do now is join them. And this is where it differs from many engineering techniques with with CAD, because what I'm going to do is I'm going to create a box corner to corner in depth, and front view, I'm going to need to go big on the front view. I'm picking up on the corner of the red, not the corner of the black. Picking up on the corner of the red, not the corner of the black. I go back into the views and I can then drag this solid as much as I would like. I'm only going to drag it 0.5 mil, which is 1 square on the grid. So now you can see in perspective, we've got this kind of flat solid that's overlaid everything else. We simply drag it into the center of all of these others. Now, if you look front to back in the perspective view, we've got all of the plank definition on the outside. Just swing it around for you. We've got all of the plank definition on the inside, and just coming back the same way. And hopefully you're not going to get too much vertigo. But you can see on the inside there, if you can just pick on it one, there you go. The yellow highlighted shows that flat solid that we've made in between. Okay, so everything's where it should be. What we now do is join them all together, and that's called a Boolean. And there's a Boolean command on the side here, and all I have to do is pick these guys one at a time. The last one that I'm going to pick is the inside one. I hit done, bit of calculation. And if I pick anywhere here, what we want to see is that all of those planks will highlight yellow, which is exactly what they do. So that's our first wall. What we're now going to do is a similar thing for the end of the wagon. So just bear with me while I go back through the process again one more time.
Lee, can you unjoin those if you decide, for whatever reason, one of the planks in the middle needs changing to a wider one or whatever?
Yeah, there is an unjoin command. In truth, I've never done that. We're going to hammer a hole through a little bit later to create the opening for the doors. And if I had realized that I've done the wrong size plank, or it's not quite as it should do, and you'll see this technique, I would actually cut away the offending piece, move what I needed to do, and then model another piece in and join them back up again. Because there's no limit to how many joining solids you put in, or anything else. So there is an undo, and I'm sure I'll get to a stage at some point where I muck up enough where I've got to undo a few commands and it goes back to what it was. It is a live demonstration. But I would tend to go at it as you would do sort of traditionally, which is the CAD equivalent of a razor saw, or a Dremel, and just drill the thing out, or cut the thing out. And it's quite happy to allow you to do that. And you'll see an example when the roof goes on, quite an extreme way of doing it, but it works perfectly well for roofs and things. So yeah, you can, it does exist that way. Okay, so I'm just aligning this front view, and hopefully this might actually help. So I'm going to extrude another planar curve, straight. I'm picking this guy, and I'm going right up to the edge of our wagon end, which is hopefully in line. Yeah, it is. So that's where we want to be. Okay. Now, again, I'm going to pick that plank. I'm going to move that plank up to where it needs to live. But in this case, you'll see that the plank is massively long. So all I'm going to do is create a little working solid, which is another box that we did the joining one. Start there, end over there, get some thickness, it doesn't matter what it is, just move it so that it goes past the solid. Different command this time, which is difference, which is basically take away. Union or Boolean is joining, difference is take away. The command asks me to pick the thing that I want to cut, which is our plank. I OK that. Pick the thing I want to cut it with, which is the box we just made. I'm OK there. And I've completely gone and screwed it. Now, the reason I've completely gone and screwed it is that I've made my box here, but my plank is all the way over there. So how embarrassing can a live show get? Probably that. So we'll try it again. Solid, difference, pick plank, pick box, pick done. And this time you see that there's a piece of plank missing. So if I delete the box, I delete the extraneous plank, we've got what we're looking for. So we're going to do the next one now. Again, extrude, straight. This time it's the smaller one. We OK that. Comes to where we want it to be. We drag it in place. Doesn't drag it in place with this one as well. So it's aligned where it should be from a 3D point of view. It's aligned on top of our drawing. We've got the same problem we had last time. I should have kept that solid that we created. But hey, corner to corner. Make sure it goes through the planks, which I didn't do last time. Solid, difference. Cancel that because I needed to do it the other way. Solid, difference. Pick plank, hit return, pick box, done. Now I can delete the rubbish. So I'm going to create a few of these. I'm going to stack them on top as we did last time. Now, all we're doing is edit, copying and pasting, just as you would with a Word document or anything else. At this stage, of course, you'll see that we've got to go higher than the sides. It's a van, so we add a few more planks. The orange curves you're seeing in the front view here are the different roof profiles. The one we're interested in is the red one. So if you go over to the right-hand side of the screen, you'll see the layer alternative roofs. I'm just going to switch that off, make life a bit easier for us. And hopefully this is the last plank we need to make. Oh. Okay, that should be the last plank we need to make because obviously the roof will take the sides. But what I'm actually going to do in this case is put one more plank in just from a safety point of view. Makes no difference to what the final outcome is going to be. I'm just giving a bit of safety measure while we're mucking about with these guys. So there they are. They're all in place. All of the data is well covered. So our next little one now is a box, corner to corner. Starts up there. You can see that it's trying to choose one of 3 points. We want that bottom point. With a 1/2 mil box, we drag that over. It should sit inside all of those planks, which it does do. So we're going to union, Boolean, join them all together. Done. If I highlight anywhere on that wall, everything comes up nice and yellow, which means that that's joined as a single solid as well. Now, it kind of gets interesting because we're still working in the one plane. We're going to rotate this end wall a little bit later, but before we do that, we're going to create some metal strapping, which are the little red bits here. Now, in the short term, these planks are going to get in the way. So I'm going to change active layer to layer 8. I'm just going to switch off the body layer so our planks disappear. We've now got a little bit more clarity to be able to see this front view and what's going on. I'm going to create a solid, simple box again. And this time it's there and there, which is the width of our strapping. I'll go into 4 views again. I'm going to create some strapping that on the face of it is going to look horribly overscale. But the reason it's like this at the moment is that we will actually move this strapping well back into the solid model shortly, but this allows good computer bonding of our straps and our planks. Now, this strapping is going to need some rivets, and way down here, I created 2 little solid spheres, and I'm going to copy one of those. Actually, the solid command has got a bunch of basic primitives up here: box, sphere, cylinder, cone, truncated cone, and so on. You can create a sphere as quickly and as simply as that. And there it is as a solid. These are some little guys I created earlier. So we copy him. Now, first trick with this is to work out where it is in space. And we're just moving him into position. Now, he's central to our solid strapping. But if we have a look at him at the moment, he's at the back. So what we're going to do is just move him over to the front there. We go to perspective. Hopefully you can just see a representation of the rivet or the bolt head coming through the solid. Yeah. So once we've got one aligned, what we now do is work out where our planks have gone. We know that this line here and this line here, where the planks join. It's an awful cheat to you engineers out there in Gajo Guild land. Okay, I've got to. Now what's happening here is that because we can choose on a dozen different points, the computer's trying to help us by being smarter than we really want it to be. So what we're going to be is done. 1.5, yeah, 1.5 is fine for this. So we're going to keep our little dimension here. We're going to move it up to the next plank. We're going to copy our little thing, and we're basically going to drop them through to where they need to live. So now is probably a good time to get that extra cup of tea. It'll take a minute or two just to drag these little guys into place.
Lee, while you're doing that,
Yeah.
are there good tutorials online?
Yeah, there are. In truth, I kicked off with a very simple model, and I learned some little commands along the way. But there's a whole almost university course that they've got on these things, and if it's something that you're truly interested in, then I'm happy to pick up on Zooms or emails or anything else to get you started. It's just little tricks to pick up, but there are lots of tutorials, and in truth, I'm only using primitive geometry for the stuff I'm doing, and I'm now getting to the stage where I'd like to do some more clever SolidWorks, and I'm going back to the tutorials to work out how to do, extruded solids through curves and this sort of thing. And it's all there. It's all easy to follow. I think the simplest way to start is with something very, very basic. I suggested originally that people kick off with a little group I'm doing in Australia with just a station running inboard. And you can sort of bash one of those out in an hour or two if you're starting from scratch. And there's enough complexity there, but it's not overwhelming in terms of the stuff you've got to do. And it gives you all of those basic commands that you're having a look at today. I was very selfish today in choosing this wagon because it's one on the list to do. I'm reasonably familiar with it, so while I'm trying to talk in CAD, which in all honesty, I'm copying this one so I don't have to go back again. Talking and CADing at the same time is not the easiest thing in the world to do. And it's really not a spectator sport either. But yeah, choose something simple, get a little bit of technique, and it's amazing how quickly you can build these things on themselves. The thing I found particularly daunting to begin with is, for the life of me, I couldn't work out how to do tumble homes from extruded planar solids, because obviously they need to go down one way and bend the other way. But that technique is basically by removing a curve from the other side now, and not dissimilar to the way the roof will come together. Okay, so we've got our solid, we've got our rivets. We're going to check in our perspective. What I'm trying to do now is just bring that perspective so we can see it. So they're all showing where they should show. Now, clearly the bar at the moment is nowhere near where we want everything else to be. But we're going to join these guys up. Now you can make bolt heads, you can make washers, and all of these things, and create a little library of standard parts. So the Talith Lin has, on its more modern stock, what best described as miniature sprung buffers, which are standard. So I've created a little standard buffer that I drop into the modern stock, and I've only ever had to create it once. Now, it's a terrible color, which I apologize for, but hopefully you can see that the little heads are now part of that solid. Okay. So what we're going to do is we're going to bring our planks back in line with our metal strapping. And I'm just looking at the best way to do that. Bear with me. Actually, I'm lying to you. We're actually going to bring our metal strap into our plank because it's going to be easier to see in the first instance. So we just drag it to the outside. Now, at the moment, that's 1/2 mil off the planks, which is a bit lumpy. Now, I tend to work in 3 or to the nearest 3 sizes. 1 mil, 1/2 mil, and 0.25 mil for metal strapping and things, which I appreciate is horribly overscale. But what I found, especially with even the fine scale 3D printing, is that anything under about 1/4 mil, by the time you've primed it, painted it and everything else, you start to lose detail. CAD system itself will work to, its default is 2 decimal places, so it's working to 3. So should you want finer than that, it'll do it and more. But for my eye and the sorts of things I do, 0.25 is about as far as I go for most things. Now, up until now, we've been snapping onto the grid. Obviously, there's no half size on the grid. So what we're going to do is move that bar back, which is up here, transform, move. And it's asking me a point to move from, which can basically be anywhere. I move up here to put my distance in. I tell it the direction I want to go. And before I click OK, hopefully you can see that the yellow is now moved back and left the outline of the black to where it is. And it's not going to play for me. There you go. So it's now locked itself in. And away you go. Now, you can see within the construction here that the plank rebates are showing extra bar. Clearly in the prototype, that wouldn't happen. Technically, if you were going to 3D print that, you could just create the bar itself, join it to the planks and leave holes behind. Although in 7mm scale, we'd never see it. If you were laser profiling, if you're doing it for etching, then clearly this would be a separate piece that would be overlaid on the top. But since this is designed for 3D printing, it's going to have these little fill-ins in the rebate. I tend to live with that. And it's a similar principle to an injection mold inside in many respects. So if that's not your beef, then it's not the only way that needs to happen with it. It's just the way that I've chosen to do it for the sorts of things that I'm doing at the moment. Now, putting those rivets on was not a spectator sport. So very, very quickly, what we're going to do is create a new one. There's 2 dimensions here. And the reason I've just pulled those up on the default layer where all our dimensions are, is that this is the little guy we're looking for, which is a center line. All I'm going to do now is go up to transform again, where we just had move, and down a few more is a thing called mirror. I can choose our solid. I hit there. I pick 2 points up on our center line. And hey presto, we've now got 2 of the guys. Get rid of the dimensions because they're just irritating. We're going to join the planks to our strapping. And there you go, we've got one piece. Now it gets exciting because we're going to join this piece to this piece. Very simply, we're going to go back up to transform. We're going to rotate because it's a 3D system. We can rotate in 3 dimensions, which is the road to madness, or we're going to rotate in 1 dimension, in 2 dimensions, which is the one we want. We pick our thing. We enter. It's asking for a point of rotation, so we're going to do that in the top view. I'm going to rotate somewhere. Let's rotate there. Okay. It's asking for an angle. Angle is 90 degrees. So we're clicking there. And if I've done this right, what we've got is a wagon end. I can now highlight, go to top so we can see it a bit bigger. just drag him to join. Now the wall thickness on this wagon is 1.5 mil, 3 little squares. Clearly the prototype wouldn't join in this way, but we've got some metal strapping to put around here, which will hide all of the nastiness. Or failing that, we could join it, we could rebate it, we could do a whole pile of things if that was required. There's no problem with that, but this is where we're at. So we're bringing our dimensions up. We want this center line. We'll transform again. We're going to mirror again. We're going to pick our end. We're going to hit enter. Pick those. And all of a sudden we've got 2 ends in the side. Let's just check that that's okay on our perspective. Yeah, okay. Now, just to finish the job, just to show you that even when we think we're as magnificent as we are, things don't always work out. We're going to mirror this one over to this side. So transform again, mirror, pick that. Now we've got a center line, but the center line is actually a center line for the chassis. It's not a center line for the wagon body at the moment. So it's not going to do what we would have hoped it to have done, but actually leave it a little bit short. Don't panic, the world isn't to an end. We pick it. And all we need to do is move it out that now. So very quickly, we've got ourselves a basic wagon structure. Now there are 2 ways, or 2 things we can do now to create this model. We can join these 4 sides together, or we can create the metal strapping and use the metal strapping to join these 4 sides together. I would tend to join these 4 sides together on the grounds that should the metal strapping go a little bit wonky, it gives us an opportunity to mess with the metal strapping knowing that the body is a robust solid. We've got internal plank detail should we want it. At the end of the day, I don't want it in this one, but it's there. It comes as if you like, no extra cost. We've got our metal strapping on the sides already in place. We only had to create one of those. So where this now starts to really pay for itself is the laborious, repetitive, creating the strapping, creating the rivets, or having to create all 4 sides, and instead of just 2 of them, it is the benefit of the process in terms of speed. Okay, so we're going to join all 4 together, to the back one, the end one, the front one, and that. Now that time it took a little bit longer for it to calculate, so there's some heavy maths going on here, but what it's now seeing is all 4 sides joined together. So we've got the basis of a wagon body. Just going to drop it back to our 4 sides. All right, next thing now is that the prototype has some little metal corner pieces, and we're going to create those in a very similar way to the strapping. We'll create one, we'll rotate it, we'll create an L section, we'll join that L section on. So we can lose our 3D body for a second, so just switch that layer off. We don't need our dimensions, so we can switch that off. We should really lose the chassis and the axle boxes, but they're kind of comforting for now, so we'll keep them. We have this profile already in place, which means that we could extrude that now should we want to as a planar curve, or we can go box to box and create it that way. So there are 2 different ways we can create the same solid. I'll do the box thing, so it's again solid, box, corner to corner. We pick that corner, we pick this corner, and then in the right hand view, we create our metal strapping. We're going to want some rivets on this again. So I've got to pick my little rivet and copy him. I'm going to move him to there, which means that he should stick out. But obviously at the moment, it's miles away from where it needs to be. So we're going to drag it over. Now the reason I'm not dragging it in one is that I want to be able to drag it from, it wouldn't let me do it. So I'm going to drag it from its end point. So it remains central to the grid. Still a long way to go, folks, forgive me. Right, it hasn't done it because it's the wrong point. Nearly there. Now, we've got ourselves a bit of a dilemma in terms of we've got a piece of metal strapping that we know is going to get moved 1/4 of a mil this way. So it's going to, once we've created our L shape, it's going to stick out in both the end by 1/4 of a mil and the side by 1/4 of a mil. Which means that technically this strapping, this solid, will actually be 1/4 of a mil that way, which means that it's going to be 1/4 of a mil too narrow for what the drawing says it should be. Now, if I wasn't in your company this evening, I'd go to hell with it. Nobody's ever going to notice it on the model. But what I'm going to do is actually show a technique where we can add a little bit more to this solid so that it's where it should be and technically correct. So ordinarily, I would take our rivet and move it 1/4 of a mil to the right so that it's central to the piece here. But if we did that now, then it's going to cause us a problem when we move the piece across. So what I now need to do is create a second one of these. And just move it there. With this little guy, I'm going to transform him to get him central now. So move, center, very similar as we did before. And this guy's now central. We need to bring our planks back so we've got some kind of idea where they're going to align. And that's pretty good because we've got the spot on. So all we have to do now is just align them with the previous ones. Which is a reasonably quick job this time. And the behaving. Yep. when I was doing the test run on this, the other 3 versions of this model, the first one I forgot to put the rivets in before I copied the strap in, and it took me about 2 hours to put the rivets around on the solid model. It wasn't insurmountable, it was just that I had to repeat myself 4 times instead of just the once. We're going to join all these guys together, so I'm going to pick that. Okay, now we're going to do the same with this. And the reason we're not copying, as I said, is we've got to move this 1/4 of a mil out. So there's a little cheat coming in a second. So they just line up again.
Lee, why don't you just Boolean your rivets together in the first place and then just copy the lot across?
What in terms of the strapping I'm now doing?
Yeah.
Yeah, I would do. If it was just for me without the demo, I would have done this one once, moved it 1/4 of a mil and pretended that this dimension didn't matter anymore. The reason I'm doing this a second time is I've got to move this one to the right, which means it will be 1/4 of a mil undersized. So I'm going to add a bit to it so it all lines up.
Okay.
If you guys hadn't been watching and marking me at a 10, I would have cheated, and I'm lucky if I can see 5 mil without my glasses on nowadays anyway. So trying to spot 1/4 of a mil on the model is nowadays neither here nor there to me, but it shows another technique if you have kind of got caught short, as it were. So again, forgive me for the time it takes, but hopefully all will be explained in a second. And this is the most time consuming. The rest of the model will come together now very, very quickly. So we've got all of those in place. I'm just going to copy this guy one more time. We're going to move him out of the way. We're going to join these little guys together now. Now this should turn black, which it's done. The reason it's turned black is that the rivets were on layer 8. Sorry, the rivets were on the body, the 3D body layer, and this guy is on layer 8, as it says here. Now, if you've made a horrendous mistake like that, what you can do is you can pick up on that and you can change the layer simply by picking on it. So even if you're kind of mixing up the layers, it's not too much of a problem. Okay, our next thing is we need to move that solid across 1/4 of a mil. So that's a transform, move, as we've done before. It's going in that direction. I just want to make sure it has actually done as it's supposed to up here, which it has. I'm bringing this guy now to there. So it's overlaid back where it should be. I'm joining those two together. And that was the trick I wanted to show you, which was because we moved it 1/4 of a mil, it was 1/4 of a mil too short. By creating a secondary solid, you can just join it to create the right length again. We're now going to move this guy back First half mil still sticks out too much. So we're transforming, moving from there in this view. And there he is, he's where he should be. The thing I don't think I made as clear as I should do is that you've got your 3 working views, and whichever one you're picking and placing on with your mouse is the way it's going to orientate. So if we try to pick on this guy and turn him through 90 degrees in the front view now, he would spin 90 degrees and go horizontal instead of vertical. By picking on him in this view and rotating 90 degrees, he will turn 90 degrees upon end, which is what we want. So we transform, we rotate, pick a center point, choose 90 degrees. We'll do that. We'll move that guy back. Now we've got 2 problems in this case, so we're going to have to transform or move them in 2 ways. One is 1/4 of a mil to the left, and one is 1/4 of a mil down. So move from. So he's moved that way. We're going to move him one more time. Move, point to move from, 0.25. Okay, so it looks as though we've got this L-shaped strap-in or bracket where we want it to be.
Hi, Jackie.
Okay, so that's where we want it to be. And we'll back to our 4 views. We're now going to join these 2 guys together. So we're going to pick there, done. And we've got 1 entity now. So very simply, top view, get our dimensions up because that's got our center line, mirror. With the mirror again. I'm going to pick this guy up. 1 more mirror.
Lee,
Sure.
Nick, hi there. I'm sorry to interrupt, and
Okay.
your meeting is absolutely fascinating, but because of the wonders of Zoom, I'm afraid I'm going to have to end this meeting so I can start the next one that's due to start in about 1 minute's time.
Can I have that 1 minute just to get my roof go on?
Apparently, I'm not able to have 2 meetings going concurrently.
Give me 1 minute to show the roof thing and all of the main geometry's done.
Right, oh, okay, that's absolutely
All
fine.
right.
Thank you.
Sorry,
Sorry,
the one
everyone.
I got carried away. We're going to extrude the roof.
Fine, it's been fascinating.
Where are we? Extrude plane the curve, straight. Roof, done. Make it as big as you want. Transform, rotate that. Now that roof, and working against the clock, which is never good for any of us, just need to line it up to where it needs to be, which is about there. It needs to line up to the red, which is almost right. Very, very quickly, and it will be done. We need to transform that roof down by 0.1 of a mil. And that means it will join on to everything else. We're going to difference the roof. So we're going to take the roof away from that. Lots of maths. We go to perspective. Do that. Do that. And that's how it comes together.
Amazing.
So hopefully that gives you some insight into how it goes. Obviously the roof would get trimmed off. We create a hole for the door. Door would be a series of planks and straps that put together. And that's your basic solid modeling. There's one other thing I promised to do, which is if all of this was joined together for 3D printing, you export your file. You're looking for a .stl file. You hit export. The triangulations that have just come up is what the 3D printer uses, and it's as quick and it's as easy as that because you've got a full solid model. Mate, you can cut me off now.
Thank you, Lee. That was an absolutely amazing presentation. I'm really sorry I'm going to have to do this because
I fully understand that.
it's just because I set up all the meetings and there was only a 15-minute gap between this one and the next one, and it's due to start in about 90 seconds. So I better go. Sorry, and thanks ever so much for supporting the show. We really appreciate that.
You are more than welcome. Let me stop sharing. Let me do one more thing for everybody if I can. If I can find the thing. If you've got a bit of paper and a pen there for anybody that's interested. That's my email address, leestyger@me.com. So if anybody'd like to follow up, drop me an email. I'm happy to follow up.